With an ASAP, within the glass models, we can easily model uniaxial birefringent materials and take into account effects such as polarization shifts as the light propagates through the crystal, as well as interference effects and other physical phenomena. Let's take a look at an ASAP file that will model this for us. And to model a crystal with an ASAP, all we need to do is define the material, and we will need two lines to the definition. The first is to provide the ordinary index of refraction, and the second is to provide the extraordinary index of refraction and the name of the material, as well as the crystalline axis. So in this particular case, our axis is oriented along the Z or the optical axis. So let's run the file and we'll take a look at what happens to the light as it propagates through this system and then goes through an ideal polarizer. So here's our light propagating through the system. In reality, that light is actually going to be broken into two separate paths, the ordinary and the extraordinary, as the light enters the crystal. And what we can see is the effect on the input polarization state, input linear polarization, after the light propagates through the crystal.